So you need to be able to identify a polynomial function from looking at the equation. Able to identify polynomial functions by looking at their equations. Okay, so polynomial function is of the form, right? All this is in your keys, ideas and stuff, but like ax to the n. Right, that's sort of very general. We're really dealing with three kinds of polynomial functions, right? So we're dealing with linear. So an example of a linear is something like y equals 3x plus 2, quadratic. And cubics. And at least as far as knowing the characteristics of them, we need to know the characteristics of a linear and of a quadratic and a cubic, right? And characteristics are such things as what? Name some characteristics. We have numbers. There's numbers in there and letters. All right, so looking at the homework, we've got degree. So we need to be able to say what degree a polynomial function is, right? Even if it's like degree 6 or 7, you should still recognize that and say, oh, that's a polynomial function of degree 5 or degree 6 or degree 7, even though you don't necessarily need to know other characteristics of it, but just be able to identify and say, yeah, that is a polynomial function, right? What else? Number of x-intercepts. So how would you figure out how many x-intercepts this one had? Graph it, right? That's all you can do. Now we know that it must have at least how many? A cubic has to have at least how many? Yeah, but at least how many? At least one, okay? Or it can have 2 or 3. What's the maximum number of x-intercepts a cubic can have? Yeah, right. 3. What's the maximum number of x-intercepts a 4th degree polynomial could have? 4. The maximum number of x-intercepts a 7th degree polynomial could have? 7. What's the minimum number of intercepts that a quadratic may have? 0, right? What's the minimum number of x-intercepts of a linear? 1. What's the maximum number of x-intercepts of a linear? 1. Yeah, right. So linear has to have 1. Linear and cubic are of odd degree, right? And odd degree functions have to have an x-intercept, okay? Even degree functions don't have to because they open up or they open down. Right? And if they open up and they're above the axis, they may have none. We know that it can have a maximum of 2, a minimum of 0, but it could also have 1. Okay? And that's where it just touches the axis. What else is in there? End behavior. So we have to know end behavior based on quadrants. And we describe end behavior as it goes from left to right. So I say the end behavior this linear function is quadrant 3 to quadrant 1. Okay, and so you just have to be able to look at something and describe its end behavior. What else is in that list? Domains. What's the domain for every polynomial function? Okay, so domain. don't know, it's best not to ask why with these things, right? Because there's no particular reason. Let's write it like this, okay? Let's get used to writing it in set notation. I noticed some people did, and I didn't take any marks off on the homework if you didn't, but I'd like to see it in this form, right? The set of all x such that x belongs to the reals. Ranges, what's the range of an even degree? Right. So an even degree has a minimum or a maximum, right? Because it opens up or it opens down. What tells us which way it opens? Leading coefficient, right? So positive leading coefficient, an even degree will open up. A negative leading coefficient, an even degree will open down. And what's the range of an odd degree? Yeah, y is an element of the reals. Okay, so every odd degree we know has to cover all real numbers, right? Whereas even degrees, greater than or equal to a minimum, less than or equal to a maximum. Number of turning points. What's the number of turning points? Or what is the possible number of turning points? So let's do this. Number of turning points of degree n. Is how many? Let's say maximum number, right? So what's the maximum number of turning points? Of a degree n. We're general here, we're not specific, right? How many yeah. Sorry? One. Degree n though. So if n is 5, you're saying there's one turning? No, you're not saying that. If n is 1, how many turning points are there? One less than the degree, okay? Hope you know this on Tuesday. It will come in, it'll come into play, trust me. It will be there for you. So, you can identify degree by number of turning points, by n behavior, right? If it opens up or down, you know it's of an even degree. And for us, we're really only dealing with quadratics, right? So you'll see degree 2. Degree 1, what's characteristic of degree 1? What's the overarching characteristic? Shall I pause this? Is it going to take awkward silence here? It's a straight line. Congratulations, right? So if you see a straight line, you know it's of degree 1. What makes it of degree 3 then? What characteristic might you see? What might you see? So what's your n behavior going to do? What tells you that this is degree 3 and not degree 1? Yeah, it's good. Basically, it's not a straight line, right? So degree 1, straight line. Degree not 1, you get a point of inflection, right? So that's degree 3. Or you get turning points. Okay. So if you see 2 turning points, then you know, okay, well that's degree 3 because we know. Welcome back. Came back for one final kick before the test is Tuesday, so it's good. You made it back time for the review. So maximum number of turning points is degree n. I know you can't. I watch videos, right, on vacation, but you can if you didn't. So, all right, you get all caught up. So, you know, we need to be able to identify: is this degree 1? Is this degree 2? Is this degree 3? We need to be able to talk about n behaviors. We need to be able to talk about how many turning points something can have. I could ask you, what's the maximum number of turning points of a degree 972 function? Right? And you say 971. Okay. because you know that it's one less than the degree, number of turning points, right? So we're not restricted there, right? I mean, even though we are emphasizing linear, quadratic, cubic, that doesn't mean that we don't know other things, right? Like in general, number of turning points is one less than the degree. That even degree functions open up or down. That odd degree functions all have a range of y belongs to the real. I could say, what's the range of y equals x to the 972? Right? And you'll say, set of all x such that, or sorry, set of all y such that y is greater than or equal to 0. Because I know this thing has to open up. And it's got a positive leading coefficient, which tells me it opens up, right? So the leading coefficient tells us the end behavior, right? And you need to be able to look at something and, deduce the end behavior from the leading coefficient. Okay, so turning points, x-intercepts, right? Number of x-intercepts, maximum number equal to the degree of the function. So if it's a degree, 816, there could be 816 x-intercepts. There could be 815 turning points. What else? So, end behaviors. Just, know stuff about this. They could all be put together, right? So a question could ask a number of things, or it could say, which of the following is not a characteristic of this function? Right? Could be, domain is the set of all x such that x belongs to the reals. No, that is a characteristic of a polynomial function. The range is a set of all y such that y is greater than or equal to 7. And you say, wait a sec, this is odd degree, so I know that that can't be the characteristic of that, right? So you X that off. That's the one you select. Oh, what else? Yeah, leading coefficient. Oh, the trailing coefficient, the constant term. What is true about the constant term? That's back here. What's true about this?
Isn't it usually the Y-intercept?
That's always the Y-intercept. That's the Y-intercept, right? That constant term is the Y-intercept. Why? Why is the constant term the Y? Which is also Y. Why is the constant term the Y-intercept? They'll all be nothing, right? You put a 0 in for x, gone, gone, gone. All that's left is the constant term, right? Constant term. The y-intercept occurs when x equals 0. You set x to 0, all of the terms disappear except the constant term. The x-intercept occurs when y is equal to 0. You have to set that to 0 and solve, which is easy with linear, right? A little bit of algebra does that. And how would you find x-intercepts for a quadratic or a cubic? Use your calculator, right? So use your calculator to find an intercept. Unless it's written in a different form, right? I mean, here, let's say that you had something let's see, it's something that's written like this. Y equals what kind of function is that? Linear, quadratic, cubic? Cubic. How do you know?
Because there's 3.
3 x's, right? So if we expanded that, we would end up with x cubed, blah, 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 right? What's the y-intercept for this? You say I was quickly calculating it. You can do this. You barely need a calculator. What's the y-intercept? It's also the answer to life, the universe, and everything, but that was coincidental. It is 42. That was coincidental. Why is it 42?
Oh, you just multiply the n numbers.
Yeah, but basically, how do you find the y-intercept? You set x to 0, which means the first term becomes negative 2. The second term is 3. The third term is negative 2 times 3 is negative 6 times negative 7 is 42. I assure you it was coincidental. I did not set out to come up with 42. Yes. It is.
Hi guys. Sorry.
No, go ahead.
I'm your Valentine's Day flower girl, and I have a flower for Chantel Vespens. Charlotte Vespens?
No, it's Chantel.
Sorry.
No, but she unfortunately is not here.
Where's her desk? Or is she going to be here later today? Or? I don't know. At all?
Well, she said she did.
Okay. Come on. So yeah, have a good Valentine's Day, guys. Bye.
If only you had friends.
Oh, what?
who gave you roses, then you would have one. Tries to recover from that. So, Dan, is this thing on? Oh, it is. All right. Well, maybe we won't post this one to YouTube. I'll just do this afternoon. Okay, so Y-intercept is 42, right? You find that by setting the X-intercept. What are the X-intercepts? 2, negative 3, and positive 7, right? You can read X-intercepts from the factored form, right? X-intercept occurs when? When Y is 0. How do I make Y 0? Well, if I get this to be 0, then everything becomes 0, since that's a factor, right? So if I set each of these factors to 0, the whole thing becomes 0. So X is 2, makes this 0. X is negative 3, makes that 0. X is 7, makes that 0. Those are the X-intercepts. Degree. Degree 3. Number of X-intercepts. 2, right? End behavior. Or I should say, okay, sketch the graph. Where are the X-intercepts? Negative 1 and 2. So here and here. What's the Y-intercept? Nope. Yep. So there's 2 of these, right? So you put a 0 in here. 0 minus 2 is negative 2. Squared is 4. Put a 0 in here. 1. 4 times 1 is 4. End behavior. 3 to 1. Why? Okay, how come? Really should go through where I put the negative 1, but yeah, it's close enough. So why does it look like this? Why not do something here? Why not do, wait, different. Why not do this? That's quadrant 3 to 1. Why is it purple and not red? Unless you're colorblind. And why is it the first one I drew and not the second one I drew?
Because find the Y-intercept, you have to go negative 2 times negative 2 because it's squared, and that will give you 4, and then you have to times that by the 1, and it would still be 4. So it has to be 4 for the Y-intercept.
Yeah, I couldn't get here with the red. Like, if I turned here, then I'm going to have to intercept the y-axis in a negative place, right? So this 0 is of degree 2, and a degree 2, we know what degree 2 looks like, right? Quadratic, so quadratics look like this. So that's why you've got that there, right? That would be the x minus 2 squared. It says that that's the shape, right? That's why you have to draw it that way, and not this way. Plus, you don't get your y-intercept either, right? Okay, health. End behaviors, more end behaviors. Oh, regressions. So you need to be able to do regressions, right? You need to be able to do a linear regression. You need to be able to do a quadratic regression. You need to be able to do a cubic regression. You need to be able to answer questions regarding that regression. So like when the x value is this, what's the y value? You need to be able to round correctly. Half marks off for rounding. So, you know, if it says round to the nearest hundredth, you can set your calculator, go into mode. Instead of float, set it to 2. It'll round everything to 2 decimal places for you. You won't have to worry about rounding incorrectly, okay? Just remember to set it back to float at some point. If you're good at rounding, then just, you know, round on the fly. I mean, that's fine. If you don't know whether you're good at rounding or not, then try rounding on the fly, and then when you get it back, see if you lost marks to rounding, in which case you might want to adjust your strategy a bit. Okay, so regressions, be able to do linear and quadratic and cubic. Make sure that you can round correctly. Applications. So the thing is, if we have an application of a quadratic, so say maybe a projectile being launched or something, then there's certain characteristics that go with that, right? Usually there's an adjustment in the domain. We don't say, oh, t is all the real numbers if it's time, right? So let's say we're launching a projectile, or, you know, throwing a football. So here's, well, let's make it a little taller. I can't draw. Here's the quarterback's arm when he releases the football. It's at a certain height above the ground, right? Depending on how tall they are and the release point, but it's probably 1.5 meters above the ground or something like that. It doesn't start on the ground, right? Even a punter punting, it's still not going to start on the ground. It's going to be very close to the ground. I mean, they don't kick it that far. Well, probably about that high. But it's not at the ground. If it's going to a receiver, then when the receiver catches it, it's not on the ground, right? If it hits the ground, then it's not a reception. It's an incomplete pass. So again, so we might have a restriction saying this is time in seconds, and this is height in meters. And we have, you know, when time is 0, what's this height? Well, I already told you, right? I mean, it's the height at which the ball was released, okay? So you're given this equation. If you set the time to 0, you'll get the height at which the ball was released, right? If it's caught, now I'd have to tell you at what time it was caught, right? Because we're not going to let it hit the ground. If I tell you what time it's caught, you could figure out at what height it was caught, right? Maybe it was a shoestring catch. It was down low. Maybe it was just a normal, you know, in the chest kind of pass. Maybe it was over the shoulder, and it was picked there. But we'll be able to get, okay, at what height was this received? If it falls incomplete, then it's going to hit the ground. Okay? If we figure out at what time it hit the ground, or if we know that the height is 0, we can figure out what time it hit the ground and know how long was the ball in the air. Right? So we can work that stuff out. We can find a maximum point. Say, how high did it get? What was the highest? We can find when that happened. At what time did it reach the maximum height? Okay? And we'll do all of that from some equation, which I haven't given you, right? But if I give you an equation, from that equation you get all that information, right? When was the ball released? Or at what height was the ball released? At what height was it caught? Oh, it hit the ground. How long did it take before it hit the ground, etc. Okay? Be able to write equations, just like in the homework assignment, right? Hey, write me the equation of a quadratic that has an x-intercept of -8. Write me the equation of a cubic that has an x-intercept of -8 and has end behavior going from quadrant 2 to quadrant 4. Right? So you need to take all this into account. So, oh, well, the end behavior tells me the leading coefficient is, you know, positive or negative, which one? The y-intercept, or the y-intercept tells me what the constant term is, and then, you know, at its simplest, I could just say -x cubed plus 8. Okay, there's your end behavior going from quadrant 2 to 4 with the y-intercept of 8. Okay, we can get a little more complicated. We will only ask you for equations of linears, quadratics, and cubics, right? We won't go beyond that. So I can ask you, give me the equation of something that has these characteristics, or draw me a graph that has these characteristics, right? So here's this degree 3. End behavior is this. Y-intercept is this. Draw the graph for me. Which actually you were pretty good at. Okay, and then being able to use stuff. All right, that's all I got. Any questions? Before I turn this off. Nope. So that covers it. You know, you got like 6 days.